Guess what today is?
It's hump day.
Hump day!
All right, so I saw the commercial this week, or actually this morning, and so it made me laugh again. Anyway, all right, so we are still solving our equations, and one of the things you'll start to notice is we're going to keep on using the same rules over and over again. We just have to combine the use out of them. So with the problems that we are going to see today, we're going to have to, what we say a lot of times is simplify. All right. What we're going to do to simplify is we're going to use our friend, the distributive property. So that's what we're going to focus on here today. We're going to see different ways of simplifying tomorrow, but today's simplifying is going to focus on using the distributive property. What you're going to find here, second, now you're going to undo any, just like before, any sort of addition or subtraction. And then lastly, you're going to undo any multiplication or and then division. So much like we saw yesterday, except we're just going to add the next layer that's onto it. So let's use that distributive property if you're ready. So we notice the 4 is up against the parentheses. So we're going to multiply. 4 times 2x is 8x. 4 times 4 is 16. I'm going to use a plus sign because, well, there's a plus sign there. And then equals 56. And now if you notice, it's, oh wait, we've seen you before. It's simply our two-step equations. So that's why we're going to undo any addition or subtraction. So to undo any sort of adding of 16, we are going to subtract 16 from both sides. So all that we've got is 8x on our left-hand side, and on the other side, 56 minus 16, that is 40. Now we're going to undo any multiplication or division. So instead of multiplying by an 8, we are going to divide by an 8 because that is the opposite. And we get an answer of x equals 5. I kind of ran out of room there. Let's go ahead. Let's look at our check step. All we're going to do is plug it into the original problem. So I've got 4 times and then 2 times 5 plus 4, and does that equal 56? I don't mind if you combine some steps here, like 2 times 5 is 10, 10 plus 4, that does give me 14. The big question is, does 4 times 14 equal 56? And it certainly does. Remember, the check step only works if you actually do the math. Shocking, all right? If you end up with an answer of, instead of 5, let's say you ended up with an answer of 2, and you're like, yay, 2 times 2 is 4, and 4 plus 4 is 8, and 4 times 8 is 56, yay, 50. No. So again, the check step only works if you actually check the math as you're going through it.
Ain't nobody got time for that.
Well, I hear what you're saying there. You probably don't like the check step because it is more work, but it ensures accuracy. So we do want to show it to you there. So let's go through the next guy. Distributive property. So 2 times x, 2x. 2 times 3, hello, 6. Set it equal to 18 because, well, it is set equal to 18. Now we'll undo any addition or subtraction. So to undo adding 6, we shall subtract 6 from both sides. So all we have is 2x equals, and then 18 minus 6 is your 12. All right. So I don't know why we got a little highlighted portion there. So to undo any sort of multiplication, we will do division. So we will divide both sides by 2. So we get x equals 6. So let's go back and let's check and see if it works. 2 and then times in parentheses 6 plus 3 equals 18. And again, all I did was substitute the x, and I said it was a 6. So 6 plus 3 is 9. So the question here is 2 times 9, does that actually equal 18? It certainly does. So I feel good about my answer. See, that one wasn't as bad. Let's go after the third one here. Again, distributive property. The number is up against the parentheses, so I'm going to multiply it to both of them. 4 times 3m. Well, 4 times 3 is 12, so I do get a 12m. I have a subtraction sign, so I keep the subtraction sign. 4 times 3, hello, 12. All right, equals 24. Again, we're going to undo any sort of addition or subtraction. So to undo subtracting 12, I shall add 12 to both sides. Let's see what we got. I have 12m on my left-hand side. On the right-hand side, I've got 36 when I add that together. So to undo the multiplication of a 12, we will divide both sides by 12. So m equals 36 divided by 12. Hello, 3. Let's see if it worked. 4 times in parentheses, 3 times 3 minus 3. Oh, a lot of 3's there. 3 times 3 is 9. 9 minus 3 is 12. So the question is 4 times 12, does that equal 24? No, 4 times 12 is 48. That doesn't work here. So I've got two options. One, I could have messed up my equation, or you're probably saying, come on, Mr. Sue Savage. 3 times 3 is 9. 9 minus 3 is, yes, it's a 6. So let's get that 12 out of there. Let's put the 6 in there. And does 4 times 6 equal 24? It most certainly does. So again, sometimes when you do your check step, it's not because of your answer, but it's because of when you actually did your check step. So you do need to watch for that. I know it's scary at times out there. It's scary out there. So let's go on down to the next batch that we've got. All right. So once again, hello distributed property. If you notice this time, the distributed property is on the right-hand side, which is fine. There's nothing to do with the 35, but there is something to do with the 5. So bring down the 35. 5 times 4 is 20. 5 times 3x is 15x. And again, we should start to notice here that we've got ourselves a two-step equation. So we'll undo any sort of addition. So we will subtract 20 from both sides. Because what is 20 minus 20? That is 0. That gets me just the 15x. Then 35 minus 20 is 15. We're multiplying here, so we'll use some division to undo it. And 15 divided by 15 is 1, so 1 does equal x. Let's check and see if it works. Is 35 equal to 5 times in parentheses 4 plus 3 times 1? Well, what is 3 times 1? 3. 4 plus 3 is 7. So the question here is 5 times 7, does that end up equaling 35? It certainly does. Check. All right, so yes, x does equal 1. Again, notice the variable is on the right-hand side, so I left it on the right-hand side. I could reverse around and say x equals 1, but we're going to see that might cause some problems here as we move forward to our inequalities. All right, so let's have at it again. 3 times 10x, 30x. 3 times 11, 33. Again, there's a plus sign, so I'm going to keep my plus sign. Bring down your 93 equals. So undo addition. So we will subtract 33 from both sides. Ooh, 93 minus 33. Yeah, that's 60. 60 equals 30x. So we'll divide both sides by 30 because to undo multiplication, you shall divide. So I get 2 equals x for my answer. Let's check and see if it worked. Is 93, does that equal to 3? Oops, the 3 should be out there. And again, if you're at this stage of the game and you're like, well, wait, could I just kind of 10 times 2 and that 20, can I just put my 20 there? Yeah, I'm fine with that. Like I said, the check step is there for your safety. So 20 plus 11 is 30, is that 33? Yeah. So is 3 times 33, does that actually equal? All right. No, that's 99. Oh, so what's wrong here? Yeah, it's not 33. It's not 33. 20 plus 11 is 30. Yep, 31. So is 93, 31 times 3, is that 93? It most certainly is, so we are good. All right, people, last one. There we go. Muster up the energy for it. Distributed property. The variable's on the left-hand side. More importantly, the distributed property is on the left-hand side. So 8 times k is an 8k. 8 times 4 is a 32. We're going to bring down our subtraction sign because it is subtraction. And we've got 48. So to undo subtracting 32, we shall add 32 to both sides. So we get 8k equals, and then 48 plus 32, that does give us 80. To undo multiplication, we shall divide, so we should get k equals 10. Let's see if it worked. 8 times, and then 10 minus 4, does that equal 48? Well, 10 minus 4 is 6, so the question Is 8 times 6, does that equal 48? It certainly does. So my answer of k equals 10 is correct. So the main thing that we're after here is all of our problems eventually become a two-step equation. We just have to do some work to get it to look like that. So in here we had the distributive property, so we could use that, and then we were able to solve our two-step equations.